Very good morning, students. Welcome to the online classes. Today in this video, we'll discuss about the chapter 11, which is midpoint theorem, and also we'll see its conversion. So let us start with the midpoint theorem. So it states that the line segment joining the midpoint of two sides of the triangle is said to be parallel to its third side and is also half of the length of the third side. Okay, so from this statement we can draw the figure like this. That means here you can see, you can take a triangle like this, triangle ABC, and according to the statement what we have got, according to statement we have the line segment joining the midpoint of any two sides. That means here the line segment EF is joining midpoint of these two lines, two sides AB and AC. That means E and F are the midpoints of AB and AC. So this line should be half of this line and also parallel to this line BC. That means the third line BC, third side BC. We have to prove this one. So now let us prove. So what are given? Given is the triangle ABC, and E and F are the midpoints of the side AB and EF. So then we have to do some constructions. We have to prove what? We have to prove EF is parallel to BC, and also EF is equal to half of BC. You have to prove. So for proof we have to do some construction. Now we'll draw a line through C which is parallel to the line AB. So we have to draw a line CD in such a way that this line should be parallel to AB. Okay, and also EF, we have to extend EF. It will meet that line at the point D. Okay, so here what we got, AB is parallel to this line CD, and this, when we extend this EF, it will join at the point D to the line which is the extended line from the C. Then to prove, what you have to do, first see, we'll write the region also, we'll write the statements, we'll write the regions. In these two triangles you can see AEF, and in triangle CDF, this triangle and this triangle, AF is equal to FC or CF, because F is the midpoint, it is given. Then angle AFE is equal to angle CFD. These two angles are equal because they are vertically opposite angles. Then this angle EAF is equal to angle DCF, because these two are alternative angles. Because these two lines BA and CD are parallel to each other by construction, and AC is the transverse here. That's why these two are alternative angles. That's why these two are equal. So in these two triangles are triangle according to the rule ASA, because two angles and one side is equal in between these two triangles. That's why you can write these two triangles are congruent. If these two triangles are congruent, then we can write EF, this EF is equal to this FD. This EF is equal to this FD, and also we can write AE is equal to CD. Understood? So this, by simplicity we can write these two, and wait, and also we can write AE is equal to B. AE is equal to B because the E is the midpoint of AE and B. Then what we will do, and also we can write BE is equal to CD, because we have proved these two are the congruent triangles. AE is equal to CD we have proved. Now AE is equal to also EB, so we can write EB is equal to CD. Okay, now you can take BCDE. These two lines are parallel. Okay, these two lines are parallel, we have constructed, and BE is equal to CD. BE is equal to CD. if these two lines are triangles, sorry, these two lines are parallel, and that B is equal to CD is equal to CD, then we can take EBCD. This EBCD is a parallelogram. Okay, if EBCD is a parallelogram, then we can take EF is parallel to BC, and also ED is equal to BC. Hence, it is a parallelogram. So one thing is proved, that EF is parallel to BC. Now we have to prove what? BC is half of, sorry, EF is half of BC. We have to prove. Now you can see here, as EF can be written as half of this ED. As it is a parallelogram, ED is equal to BC. We can replace ED with BC. So we can write EF is equal to half into BC, like this. Okay. So hence we have proved that EF is parallel to BC and EF is equal to half of BC. So this is the midpoint theorem and its proof. Then we have a converse of midpoint theorem. The converse of midpoint theorem states that if a line is drawn through the midpoint of one side of the triangle and parallel to the other side, it bisects the third side. It is the converse of that one. In this also we can see. Okay. So what is given? Given a triangle, E is the midpoint of AB, and a line drawn through E parallel to BC. So this line drawn parallel to BC. So it meets the AC at point F. Okay. So now what we have to prove? We have to prove AF is equal to FC, so that we can prove that F is the midpoint of AC. Okay. Then we have to do some constructions. We have to do some construction like this. Through C, we have to draw a line, which is line M, which is parallel to AB. This line we have to parallel to AB, and the secondary line L is meet at the point D to the line M. Okay. So then for proof, what you have to do? So here this EBCD is a parallelogram, because we have one is given and this is given, and this is we have constructed. So this is a parallelogram. So we can write BE is equal to CD. This BE is equal to CD, and also we can write EA is equal to BE, because E is the midpoint. So we can write EA is equal to CD. Okay, this EA is equal to CD we have wrote. Then take these two triangles. These two lines are parallel. This angle should be equal to this angle, because they are alternative angles, vertically opposite angles, and this angle is equal to this angle, because they are vertically opposite angles. Sorry, alternative angles. This one is vertically opposite angle. This one is vertically opposite angles. This one is the alternative angles, because these two lines are parallel. We have, from construction we know, and we have proved AE is equal to CD. So according to the rule AAS, the triangles, this triangle should be is congruent to this triangle, according to the rule AAS. So by the CPCT, we can write AF is equal to CF. As these two triangles are congruent, then you can write AF is side AF is equal to the side FC of this triangle. Okay, hence it is also proved. F is the midpoint of AC. So thank you. In the next class we will see the question answers of this chapter, and now you are ready for the question answer of this chapter 11. Okay, what we left we'll do that in the next class. I hope I have covered all the things. If something left, then I will do it in the next class. So in the next class we will see the intercepts and theorem on intercepts. Okay, so this I have left, I think. Okay, in the next class we will see this. So thank you. Have a nice day.